Today we're going to be looking at problems involving limiting reagents or limiting reactants. What makes these problems different from the other problems that we've done in the past is that you're going to be given quantities of two of your reactants and asked to determine the quantity of the product. Your job is to figure out which of the two reactants is used completely up while the other one would be in excess. So there's several different things you're going to be looking at on these particular types of problems. First of all, the limiting reactant or reagent is the substance that gets completely consumed in the reaction. It will limit the amount of product that is produced because once it's all used up, then the process will end. The excess reagent, and I'm going to use LR for limiting reagent or reactant just to make it simple. The excess reactant is the substance that you will have in excess, which means it's not completely used up in the reaction. So you're going to be asked to determine which of the two reactants is the limiting reagent or reactant and which is the excess reactant. Then you'll also be asked to determine how much product you could produce. In order to get the amount of product you produce, you're going to do mass problems, starting with the quantity of the limiting reactant and go on to the product. So we'll look at some examples as we go. When you work these types of problems, like I said, you're going to have two quantities of the reactant, and your job is to figure out which one's the limiting reactant. There's going to be 5 possible questions that you can answer. So here are the 5 questions that you will answer. 1 is which is the limiting reactant. 2, which is the excess reactant. 3, how much product can be made. You're going to do those 3 all together by doing 2 stoichiometry problems, and I'll show you that in a moment. Once you determine those 3 things, then you can determine how much of the excess reactant is used and then how much is left over by doing a 3rd stoichiometry problem. So we'll work through this one. This one's a little long because you have 3 different stoichiometry problems you have to work. So you can read through these. You're going to start with one of the reactant, find out how much a product is made. You'll start with the second reactant, find out how much product it is made. Whichever of these 2 makes the least amount of product, that is going to be the limiting reactant. Remember, it has to be a reactant. So it's one of the 2 starting materials that you start with. Once you determine which is the limiting reactant, then you can determine how much of the excess reactant is going to be used by starting with that limiting reactant as well. So this just kind of goes through all these particular steps that you can do. Once you have determined how much of the excess reactant is used, then you can determine how much is left over by simply subtracting the amount of the excess reagent you started with from what you found out being used. So let me walk through a problem with you. It says how many grams of ammonia can be produced from the reaction of 28 grams of nitrogen and 25 grams of hydrogen. So here we have our balanced equation that we've used many times. The difference here is you can see when you're working on this one that we have 28 grams of this substance and we have 25 grams of this one. So we actually have 2 different quantities of substances we're starting with, and we're going to be looking for X grams of ammonia. So this is a mass problem. What you need to do on this is take each one of these reactants to product, you doing a stoichiometry problem. So you're going to do 2 stoichiometry problems. The first one you're going to do, you're going to take your 28 grams of your nitrogen, and we want to go to X grams of ammonia. The second one you're going to do, you're going to take your 25 grams of hydrogen and go to X grams of ammonia. So you're doing 2 mass problems in this particular beginning. So I'm going to start off with my 28 grams of nitrogen. I know that I have 2 nitrogens, which will be 28 if I multiply the 14, and 1 mole. So we're going to convert our grams to moles. So this is what we've done before. We do grams to moles, then we do our mole ratio, and then we're going to do moles back to grams. So you're still going to follow those same steps that we did earlier. All right, so now that we have our grams to moles, the next thing we're going to do is our mole ratio. So we're going to use our 1 here to our 2 here. So our 1 mole of nitrogen goes here. 2 moles of ammonia go here. And then finally we're going to go ahead and go on to grams. So we know 1 mole of ammonia is equal to 17 grams of ammonia because nitrogen is 14. Hydrogen is 1 times 3. So 3 and 14 is 17. And then the rest is just doing the math. So it's, of course, 28 divided by 28 is going to be 1. And then 2 times 17 is going to be 34. What this is telling me is if that all 28 grams of nitrogen is used up, 34 grams of ammonia could be produced. Now our second part is we're going to start off with the 25 grams of hydrogen and do the same thing. We'll go grams to moles. So we know 1 mole of hydrogen is equal to 2 grams of hydrogen because each hydrogen is 1. So grams of hydrogen will cancel. The next thing we will do is do our mole ratio. So we have our hydrogen has 3 to our ammonia with 2. So I want to put my 3 hydrogens here on the bottom, to my 2 moles of ammonia on the top. Moles of hydrogens will cancel. And then finally, 17 grams of ammonia on the top to the 1 mole, so that the moles will cancel. And again, we're doing the math. So we've got our 25 divided by 2 times 2 divided by 3 and then times 17. This gives me 141.67. So this is telling me that if I used all 25 grams of the hydrogen, I would make 141.67 grams of ammonia. So the next thing I want to do is I want to look at my 2 amounts of product. I'm going to pick the lower one. That's exact the amount of product that I can make. So the reactant that limited this quantity was my nitrogen. So based on these 2 problems, I can answer 3 questions. The first one I can answer is whichever of these is the lowest quantity, that's the amount of product I make. The second thing I can answer is whichever of these I started with made that amount, in this case the nitrogen is my limiting reactant. Which means that my hydrogen has to be my excess reactant. So those are the 3 things I can answer by doing these 2 stoichiometry problems. How much product I made. To determine that, I just look for the smaller amount. That's the one that is limited to the quantity I can make. Because when all 28 grams of the nitrogen is used up, that's what I make. I can't make any more. So that's my limiting reactants, my nitrogen. The other reactant, which was the hydrogen, is going to be my excess reactant, and then the amount of product I made, which was the smaller of the 2, is 34. All right, so we've already done that. So now we want to determine how much of the excess reactant was used. So again, we'll just write our equation again. So our nitrogen, our hydrogen, and our ammonia. We know we used all 28 grams of this, so we've got to start with this. And what we want to do now is figure out, well, how many grams of the hydrogen do we actually need for this particular reaction to take place? I know I had 25 grams, but I know I didn't use it all because it was the excess. So now I'm starting with a third stoichiometry problem. I'm going to take my 28 grams of my nitrogen, And I want to take it to grams of hydrogen. So a third stoichiometry problem. Take your limiting amount and figure out X grams of the excess amount. So this will start just like we did before. We had 28 grams of nitrogen in 1 mole. Do our mole ratio between the limiting reactant and the excess reactant. So we have 1 mole of nitrogen on the bottom to 3 moles of hydrogen on the top. Again, I'm getting these off of these coefficients from the balanced equation. And then finally, I can take my moles of hydrogen to grams of hydrogen. I know there's 2 grams of hydrogen in 1 mole because each hydrogen is 1 times 2. And then the rest is doing the math. So 28 divided by 28 is 1 times 3 times 2 gives me 6 grams of hydrogen. This is how much of the hydrogen or how much of the excess reactant was actually used. So to find out how much is used, you take the amount of the limiting reactant that you started with, in this case the 28 grams, and find out X grams of the excess. That's our 6 grams. And then it asks us how much of the excess reactant is left over. So if you go back and look at the original problem, it told us that we had 25 grams of hydrogen that we started with. We used 6 grams, as we determined in the problem just before. So all we have to do now is subtract the 2, and I would get that I would have 19 grams of hydrogen that would be left over, or in excess. Which means that whoever set this problem up wasted a lot of hydrogen, didn't they? All right, let's look at one more of these. All right, this problem, it says you have silver nitrate and sodium phosphate reacting in equal amounts of 200 grams each. How many grams of silver phosphate are produced, and determine the limiting and excess reactant. So to do this particular problem, I've got to do 2 stoichiometry problems. But before I can do that, if it's a reaction stoichiometry, then I have to write a balanced equation. So I've got silver nitrate Remember, silver is one you memorized for having a +1 charge. Nitrate is a polyatomic ion, NO3 with a -1 charge, so that doesn't need additional subscripts. I'm reacting it with sodium phosphate. So sodium is in group 1A, so it has a +1 charge. Phosphate is a polyatomic ion with a -3 charge, so that means I'd need a 3 on my sodium. So again, this goes back to having to write your correct formulas for your particular compounds. If I look at this, I have 2 compounds, so I'm basically going to produce 2 new compounds. It tells me one of them is silver phosphate, so that means the silver and the sodiums are going to change places with each other. So one of them is going to be silver with the phosphate. Silver, remember, is +1, phosphate -3, so I need a 3 on my silver. And then my other compound is my sodium with my nitrate. Sodium's a +1, nitrate's a -1, so it doesn't need additional subscripts. So this one's making you go back, write formulas, balance an equation, and then you do the stoichiometry part. So this one takes a little bit more effort because you have a lot of things you have to do here. So the first thing I'm going to do is balance my equation. So I'm going to have a 3 here. I'll have a 1 here. I'll have a 1 here. And I'll have a 3 here. Now you can go through and balance this one if you need to. If you'll notice, you have nitrates on both sides, so you could use that as 1 unit. You have phosphates on both sides, so you use that as 1 unit, and then do the balance. Then you can see that I got 3 silvers here, 3 silvers here, 3 nitrates, 3 nitrates, 3 3 sodiums, 3 sodiums, 1 phosphate, 1 phosphate. I'm going to change colors just so we can see our work a little better. So it tells us that we have 200 grams of both of our reactants, and we're looking for X grams of our sodium phosphate. So I need to do 2 stoichiometry problems, both of them starting with 200 grams of one of them with the sodium nitrate, one of them with the sodium phosphate, and I'll be going to the silver phosphate. So it's a mass problem. So the first thing I'll do is take my grams to moles for both of these, do my mole ratio, so go to moles, and then finally moles to grams. Once I get these 2 problems worked, then I should be able to answer the 3 questions that they ask me. So let's go ahead and do this. So I'll have 200 grams of my silver nitrate. I know 1 mole of silver nitrate is equal to its gram formula mass of silver nitrate. So silver is 108. So I'm going to do it up here. We only have 1 of those. Nitrogen is 14. We have 3 oxygens, so that's 16 times 3 or 48. So I'm getting 170 here. So that'll get me to my moles of silver nitrate. The next thing I want to do is my mole ratio. So I have 3 moles of sodium nitrate to 1 mole of silver phosphate. So I'll put my 3 moles down here so that can cancel. The 1 mole of silver phosphate up here. So that was my mole ratio step. And now finally we need to go from moles of silver phosphate to grams of silver phosphate. So I know 1 mole of silver phosphate is equal to its gram formula mass. There should be a 3 here, if you can see it. So I have 108 times 3, which is 324. I have 1 phosphate, which is 31. And I have 4 oxygens, that's 16, which is 64. So if I add all that together, I get 419. So now I'm going to carry out the math. So I have my 200 divided by my 170 divided by my 3, and then times my 419. And I'm getting 164.31 grams of the silver phosphate. That's telling me that if I use all 200 grams of the silver nitrate, I'm going to get 164.31 grams of the silver phosphate. But I don't know if I did that or not because I got to see if the other one might be the limiting reactant. So my other substance was 200 grams. Let me change colors again. So I have 200 grams of my sodium phosphate. We're going to do the same exact thing here. So now we want to take our grams to moles. So we're following these same 3 steps down here. So I know 1 mole of sodium phosphate is going to be equal to, sodium is 23, so 23 times 3 is 69. You have 1 phosphate at 31. We have 4 oxygens at 16. So if I add all that together, I get 164. So let me check that, make sure I did that right. 69, 31, and 64. Yes. All right, so that's going to be its gram formula mass will go down here. Now that we have moles of sodium phosphate, I'm going to go to moles of what I'm looking for, which is my silver phosphate. So now I want to use my mole ratio. So it's a 1-to-1 mole ratio. So 1 mole of the sodium phosphate to 1 mole of the silver phosphate. And again, I'm getting these 1s from my coefficients in this balanced equation. That'll cancel out the moles of the of the sodium phosphate. And then finally, I want to go moles back to grams, so we're going to use the same basic last step. So 1 mole of the silver phosphate is equal to 419 grams of silver phosphate. Moles will cancel. And now the rest is doing the math. So I'll take my 200 divided by my 164 times my 419. And that's going to tell me that I have 625.37 grams of the silver phosphate that would have been produced had I used up all 200 grams of the sodium phosphate. Now that I have these 3 problems, I should be able to answer the 3 questions they asked me. So how much of the silver phosphate is produced? All I have to do is look at the 2 quantities I produced over here and pick the smaller one. So 164.31 is the amount that I would have produced, because once I produce that much, all of my silver nitrate is used up and I can't continue with the reaction. Once I determine how much of the product is made, then I go back and look at the beginning and see which reactant made that. It was the silver nitrate, so my silver nitrate is my limiting reactant, which makes my sodium phosphate my excess reactant. So again, pick the smaller of the 2 products that are made, so it'll be 164.31. That's the amount of product that is made. Go back to the beginning, find out which substance made that. That would be the limiting reactant, which is the silver nitrate. The other one is the one that's in excess, or the excess reactant. Now, if I want to answer the other problems or the other questions that would be here, how much of the excess reactant is used, then we would start off with our 200 grams of our silver nitrate, because that was our limiting reactant. And we want to go to, from silver nitrate, we want to go to our sodium phosphate and find out X grams of this. We know we start off with 200 grams, but we know we also didn't use it all. Okay, so if we go back, remember this is a 3 here, and this was a 1 here. So those are my coefficients that I'll need. So the first thing I'm going to do is my grams to moles, just like we always do. So grams to moles here. I figured out that the amount of grams, if I go back a couple slides, we'll look at just so you can see. The amount of grams was 170. That's our gram formula mass for the silver nitrate. That's how many grams are in 1 mole. That'll cancel. Then I'll do my mole ratio. So I have 3 moles of the silver nitrate to the 1 mole of the sodium phosphate. Remember, I'm getting this from the balanced equation. So again, I'm going to back up a couple slides so you can see. So here's my 3 to 1. And then lastly, I'm going to take my moles of my sodium phosphate to grams of sodium phosphate. And again, we figured that out earlier as being 164. So again, we'll look back real quick and you can see that 164 was the moles, the grams in 1 mole. And now the rest is doing the math. So I went grams to moles like we did before, mole ratio like we've done before, moles to grams. So if I calculate this out, I'll have 200 divided by 170 divided by 3 times the 164. So the amount of excess reactant that is actually used is 64.31 grams. And then if I want to figure out how much is left over, remember we started off with 200 grams of the sodium phosphate. So if you go back and read the original problem, we just determined that 64.31 grams of sodium phosphate was actually used. So all we have to do is subtract what they gave us initially from what we just determined as being used. And you're going to have 135.67 grams of sodium phosphate left over. So try some of the others. There's some others that are probably on your handouts, but this should give you the general idea. You're going to do, just kind of as a quick review, you're going to do 2 stoichiometry problems to start with. Spelling spell. Taking each reactant to the product. Select the amount of product. I'm going to abbreviate a little here. That is the smallest. And that's going to be equal to the amount of product made. Then you're going to back up and see which reactant made that smaller product. That's going to be your limiting reactant. The other reactant will be the excess reactant. So you're going to do that with 2 stoichiometry problems initially. So that answers 3 of your questions. The amount of product made, which substance is the limiting reactant, which substance is the excess reactant. So I'm going to back up a slide so I have some space to write. Okay, then you're going to do a 3rd stoichiometry problem. You want to start with the amount of the limiting reactant, and you want to solve for X grams of the excess reactant. This is going to determine the amount of the excess reactant used. And then finally, you'll take the initial amount of your excess reactant given in the problem, subtract that from, well, subtract the amount used from that, and that's going to be the amount of the excess reactant left over. If you follow those steps, you shouldn't have any problems with these kinds of things.